Welcome to today's webinar on Is Your Sensitive Data Playing Hide and Seek with You? My name is Phil Ryman. I'm the Director of Business Development at Integrity, and I'll be the moderator for this e-learning session. The speaker today is Stephen Coast. Steve is the Chief Technology Officer and founder of Integrity Corporation. He's been working with Oracle products since 1994, and has for the past 17 years. Steve has focused on the security and auditing aspects of the Oracle products and EBusiness suite and the database, and has written and presented on these products at various national and regional conferences, including OAUG and the National Collaborative Conferences. Steve is recognized internationally for his vast security knowledge and his expertise. I'll now turn it over to Steve.
Thanks so much, Phil. So today's presentation is regarding sensitive data in your Oracle databases. And those Oracle databases may be supporting large ERP systems like Oracle EBusiness Suite, PeopleSoft, SAP. And what we're going to focus in on is you've got sensitive data in these databases. You may know where some of those elements are, but oftentimes we call it hide and seek. Your data is playing hide and seek with you, that it's hanging out in your database and you may not know where it is. And so this presentation is going to talk about how do you actually find that data? Where is it? Where might it be? And it's really based off a lot of the work that Integrity does with our clients, doing sensitive data assessments, looking for this data. And oftentimes we are finding sensitive data elements in 30, 60, 100 different places in these large enterprise databases, even though our clients think it may be in like 10 places. Generally, it's 2 to 3 times as many locations as the client has. If they even have a sensitive data inventory, it's often in 2 or 3 times as many locations at a minimum. And we've seen up to 10 times for some clients that it's scattered throughout the database and they just don't understand where this data is. And so this presentation is going to walk through how do we solve this challenge? How do you figure out where this data is? Where may it be hiding in the nooks and crannies of your databases? Before we get started, a brief background about Integrity, give you a little bit of foundation about where we're coming from and kind of our insight into these problems. So Integrity was founded in 2001 by former Big Six consultants working on large ERP implementations. So we're really based off of that foundation. How do you actually manage these large ERP applications, databases in the enterprise and make sure that they're secure? So Integrity does that one of 2 ways. We have a set of products, the first being AppSentry, which is a tool that validates the security of your Oracle EBusiness Suite, PeopleSoft, and databases. And when we talk about databases, we're talking about Oracle SQL Server, DB2, Sybase, MySQL, and a bunch of others. And AppSentry is actually a tool that will go through and validate a lot of this and actually has a component that will actually search for sensitive data in your Oracle EBusiness Suite environment. We also have a proactive tool that's a layer of defense called AppDefend. So if you are running Oracle EBusiness Suite and PeopleSoft, AppDefend will provide virtual patching, a layer of defense to defend your Oracle EBusiness Suite and PeopleSoft environments, especially if they're on the internet. So we'll actually virtually patch Oracle critical patch vulnerabilities that may be in your system that you may not be able to patch for a week, a month, a year. In some cases, we've got some clients who are unable to apply security patches due to poor customizations and things like that. And AppDefend is a very good mitigating control for Oracle critical patch updates. Where most of this presentation has come from is from our services in terms of doing security assessments on site, helping our clients solve SOX, PCI, GDPR, HIPAA, those type of challenges. And they need to know where their sensitive data is. So a lot of this work that we do every day with clients trying to find the sensitive data in their environments, how do you protect it? How do you implement tools in terms of encryption, database vault to actually protect this data? So that's mostly where this presentation is coming from. So we actually do this every single day at large enterprises trying to secure this data, including social security numbers, credit card numbers, bank account numbers, those types of things. And then finally, the last piece of Integrity is our research team. So we're backed up by a world-class research team internally that is finding many security vulnerabilities, many issues within the Oracle product stack, and actually actively working on ways to actually protect the data within these databases. So enough about Integrity. Let's kind of jump into the topic and start talking about sensitive data. And we'll kind of talk about it as an overview. When we have the term sensitive data, what are we referring to? And unfortunately, the term sensitive data means a lot of different things to different people. Then where may it be in your databases? Next is how do you actually discover it? And then finally, how do you actually protect this data? And then we'll open up some question and answers at the end. So if you do have any questions, please enter them into the questions box within GoToWebinar. So let's start talking about sensitive data at a very high level. What is sensitive data when we're talking about it? And unfortunately, there's not really any good answer here. Sensitive data means different things to different people. Generally, most people back it up to compliance standards. So they kind of say, okay, what do we have to be compliant with? Therefore, that's the data we're most concerned about. And there are a couple of compliance standards that are very specific about what sensitive data is, what you need to protect. The three that we work with significantly starts with the Payment Card Industry Data Security Standard, or called PCI. PCI is very much dedicated to credit card numbers. So if you are accepting credit card numbers, you need to be PCI compliant. So within your Oracle databases, you have credit card numbers in those databases, they must be PCI compliant. And PCI has very rigorous standards about what you must do to secure your environment, your databases, your applications in order to store those credit card numbers securely. The next standard that has really come up recently, because it was actually only a year or two old now, is GDPR, which is the European Union's General Data Protection Regulation. And GDPR specifies that individuals' personal information must be well protected. Unfortunately, GDPR does not have a very detailed definition of what personal information is. So it can be actually fairly broad. And within the GDPR regulations and articles and recitals, it lays out how you must be controlling this data, controlling access to the data, how you actually have to retain the data, how long you can retain it for, how often you actually have to get rid of it. And if someone comes up and says, I want to have you get rid of my data, that's part of the regulation. And then finally, HIPAA is another standard that we often run into. Again, HIPAA is around health information, so protected health information. Again, fairly broad about what that means. It means different things to different organizations. We even have some clients who are medical device manufacturers. Because they're selling directly to their patients, their accounts receivable is HIPAA information. So they must be protecting their accounts receivable differently than a normal organization would have to protect their accounts receivable. So again, what sensitive data really matters to the organization is very specific to the organization. Some organizations have a very broad definition of sensitive data because of the industry they're in or the regulations they have to comply to. Other organizations are very narrow. So it's really depending on what you need to do in terms of sensitive data. But most of this presentation will be generic. So we're looking for these classes of data within the database and where they may reside and what might happen. Another area that's really coming up recently is the state privacy regulations. So California had a regulation for a while, and there were some other ones. Massachusetts has a pretty rigorous standard. But recently, a couple states have actually come online with very detailed regulations. The first one being the California Consumer Protection Act, Privacy Act. That becomes effective January 2020. Maine has actually outdone California, so the state of Maine has even a more rigorous standard, and that becomes effective July 2020. And the Maine standard actually requires reasonable measures to protect consumer information. And as you can kind of see, most of these laws and regulations are very broad in nature. They're not very specific. They're not something that you can just hand to a DBA and say, oh, go protect all our Oracle databases. Here's the Consumer Privacy Act in California. They're not to that level of detail. So unfortunately, in most organizations, there's often a disconnect between what the DBAs are doing or what they think they need to do and what the actual regulations are. So there has to be a fairly rigorous effort within an organization to define this out. What do we have to comply with? What data elements are we thinking about? And because at the end of the day, most of the state laws, even some of the national laws, GDPR, all relate back to breaches. So if you are breached, what happens? What do you need to do? And what kinds of data elements, if those are breached, do you actually have to notify people? Are they encrypted? Are they unencrypted? So it's very important to understand where these data elements are and what data elements you're looking for. So let's kind of get into the definition of sensitive data. So again, this is very specific to every organization. Every organization's list of sensitive data elements will be different. there'll be a lot of commonality, but depending on your industry, what kind of data you are consuming in your databases really depends on what level of detail you need to go to. PCI is the most rigorous, simple one. Again, it's credit card numbers. So if you are storing credit card numbers in an Oracle database, that Oracle database must be PCI compliant. So you must understand exactly where those credit card numbers are within the database and how you're protecting them. And so the definition of a credit card number is actually the primary account number. That's the 16-digit number on like a Visa, and then also the 3 digits on the back of the card. Again, those lengths and digits change based on the type of card between Visa, MasterCard, Amex, Discover, etc. Another PCI element is magnetic stripe data. Very seldom do we actually ever see that captured in standard applications and then stored in an Oracle database. Most often that's at the point of sale processing, it may be in the point of sale terminals, but very seldom does that data ever actually get into an Oracle database. Most people are actually pretty good about not storing that. So primarily with PCI, we're concerned about the credit card numbers and then the CVV codes that go with those. For privacy regulations, including GDPR, we're typically concerned about people's personal information around the first and last name. And most of the regulations are written, at least at the state level. GDPR is a little bit broader, but at the state level, most of them actually lay out if you have first name, last name, and some sort of account identifier. So the account identifier could be social security number, credit card numbers, bank account numbers, et cetera, even driver's license number. If you're storing those elements together, therefore you must comply with the regulation. And if that information is breached, and oftentimes if it's not unencrypted, you then have to do a breach notification. For HIPAA, HIPAA is fairly broad in terms of you must have personally identifiable information that's health information that then is associated with some individual's identifier, and that may be first name, last name, that may be a social security number, that may be a health insurance number, that may be an internal code, but it all has to be related together. But the definition of protected health information is actually pretty broad. So most people will think, okay, it's the health records, it's that information, that a diagnosis code, those types of things. But it actually also includes like payment information. If you're doing a payment and you can identify what that payment is for, even an invoice, an inbound payment, if I can then map that back to a diagnosis code, that's health information. So every time when you actually send out an invoice from a healthcare provider, it typically has enough information that would cover it as protected health information. So again, this is a very broad, high-level definition. GDPR can go much deeper in terms of what you need to be looking at. But generally, these are the types of elements that we're at least looking for on the first pass on a very high-level type of assessment. Again, things like social security numbers, bank account numbers, credit card numbers. That's the information that if it is stolen can actually injure your employees, customers, vendors, if that information is lost or a breach. And that's typically the focus on most of these exercises. But again, you can go very deep in this, like on payroll information for employees, salary information. Some organizations consider that sensitive data also. And again, based on your policies and procedures within your organization, that's usually the best place to start. What do we consider sensitive information, personally identifiable information do we need to look at? So where might this data be stored in a database? The classic place in a database would be in different tables. So most people, when they're thinking about this information stored in a database, I'm thinking about it stored in a table. So typically credit card numbers. And what we're going to now here is break out, okay, when we talk about credit card numbers, what are we talking about? Well, I have inbound customer credit card numbers that then are stored in the database. Someone orders something, they provide their credit card number, will be stored in the database. So that's kind of a very classic place. How about your employee corporate cards? So oftentimes those are also stored in the financial system. So again, when we're talking about some of these elements, they may be stored in multiple places because there's different types of those values. Social security numbers become a very interesting one because, again, for an HR system, it's very obvious that I have my employees' social security numbers. That's how I have to do payroll. That's how I have to pay them. But how about my accounts payable? Well, I may have tax IDs for my vendors, and if it's a corporation, they'll have it FEIN. I probably don't consider that protected information because that's actually included often on invoices and things like that. But how about my individual sole proprietorships, my people who I'm doing 1099s on? all of a sudden my accounts payable will actually have Social Security numbers. And within that data, I will have different types of tax IDs. I will have tax IDs that are corporations. I'll have tax IDs that are individuals. So now may have a single table in my application that has a table of tax IDs for my vendors, but there'll be actually a mixture of those values. Some will be Social Security numbers, some will be FEINs, some may be international. In some cases, I may be capturing Social Security numbers for customers. We often see when I'm actually extending credit to customers, I may those tax IDs in order to look them up, do some due diligence on them. So oftentimes we see as part of the customer records now within the accounts receivable system that if, again, a sole proprietorship that's a customer that I'm extending credit to, I may have accepted their tax ID and it may be within my accounts payable system. So as now you can kind of see it's not that obvious. It's not, oh, employee Social Security numbers. Yeah, we need to protect that. But I may be having Social Security numbers from other sources also within my environment. So now I have to look in multiple places and the data will be commingled with different types of data. So I'll have FEINs, I'll have Social Security numbers. I may actually have European tax IDs. Bank account numbers. Again, I'm accepting bank account numbers from different places. I have bank account numbers for my company. Within the enterprise will have its bank accounts. How much do I need to protect those? That becomes a question for the organization. If I have payroll HR, I most likely will have employee bank account numbers for direct deposit. For my accounts payable, I'll actually have bank account numbers for my vendors. That bank account may be for a vendor that I'm making a payment to, maybe an individual, not a corporation. So again, within like GDPR, that is protected information. And again, now I've got a table of bank account numbers for vendors. I may have some that are GDPR, within scope of GDPR, some may not be. So that's where this now becomes interesting because the data is commingled. It's not easily stored in just one table. I know exactly where it is. Life is all good. I can protect that one table. I may have dozens of tables, as you can see here. These may also come out within the application. There may be a couple tables that store this information for each common element here. So let's kind of jump into a couple applications, actually looking at real life applications. And I'll actually pick on two applications that we work mostly with. They're great examples though. One is Oracle EBusiness Suite and also Oracle PeopleSoft. So when we start talking about like Oracle EBusiness Suite, where is this data within these applications? So for credit card data, if you're running the latest version of Oracle EBusiness Suite, it should be an IBY security segment. However, if you're running older versions or you did upgrades over time, you actually may have credit card numbers in a large number of tables. So as you can see, this list of tables it should be an IBY security segment, but we often find it in these other tables because you may not have upgraded, you may have older versions. There's a lot of reasons that it may be in those places. For Social Security number, again, within the Oracle EBusiness Suite, Social Security number is not called Social Security number. It's actually called National Identifier. So for employees, it's actually in the National Identifier column. So we've actually seen some cases where the auditors came in or someone came in and looked at this, maybe from IT security, and they looked at, okay, let's look for Social Security numbers. They didn't actually find any columns called Social Security number, nothing called SSN, because within Oracle EBusiness Suite, it's all called National Identifier for employees. Because again, they're not storing just Social Security numbers, they're storing national identifiers for every country. So if you're in the United Kingdom, it may be the National Health ID. Different countries will have different names for a lot of these elements. So they store it in a table called National Identifier. I also have accounts payable, purchasing, and again, now I've got tax IDs. I've got 1099 tables. So within an Oracle EBusiness Suite, if you're running both financials and HR, you have at least 6 locations where Social Security number will be readily contained. You may have more. For bank account numbers, Oracle EBusiness Suite does a pretty good job about consolidating those bank accounts into a couple tables. Even the direct deposit information is really stored in the same tables as other locations. But again, these bank account numbers may be stored in other tables because when they cut a check, they actually will put the bank account number again. So one company's bank account number, one employee's bank account number may be in 2 locations, just the way they store the data, because they would need to know if you change bank account numbers, they need to know where the last direct deposit went, so they don't updated everywhere, they keep that old bank account number in the system also. So you've got this history within the application going. For protected health information, again, I may have it as part of human resources, be it for my employees, it may be accounts receivable if you're a device manufacturer, those types of things. It may be in order management. And again, it's what elements are you actually capturing as part of these applications is very important. Applications do protect this information in some cases, and this is then becomes very dependent on the application. So if we look at just Oracle Business Suite at a very high level, when we start talking about these sensitive data elements, well, are they encrypted? Are they actually protected in the application? And many applications don't protect this information. So Oracle Business Suite only encrypts credit card numbers and bank account numbers. So it's highly dependent on what the application is doing to actually protect this information. And in some cases, like Oracle Business Suite, Social Security numbers are not encrypted. There's no native protection. Social Security numbers through Oracle Business Suite are just another piece of data. There is nothing special about it, where an application like PeopleSoft does a much better job of protecting that. So when you're looking at the applications and saying, okay, yes, we need to start looking at sensitive data in the organization, let's start with like Social Security numbers. This is application by application dependent, and then those applications are using the Oracle database. And so there's no simple way to solve this problem by, if you've got 10 applications, you need to look through 10 applications and say, okay, does this store Social Security numbers? Would this be one that does or does not? And most people, when they start that type of exercise, look at, okay, let's look at payroll, human resources, because we know I've got employee Social Security numbers in there. But then they forget to go look at the financial system, accounts payable, because again, I've got 1099 Social Security numbers in there. And if I lose that information, that is a breach, and therefore I have to do a breach notification. So it's very important to think about this as an applications perspective. Each database is a snowflake. It's very unique. So when we start thinking about this, we need to look at each one. So if you think at it as an application table level issue, is a good way to start, because again, the application is storing data in the tables, and I need to focus in on that first. So I may know where that is. My development team may be able to give me a really good list of that. My application vendor may be or may not be able to give me that list readily. The question now becomes, where else might that be stored within the database? And if we start thinking about this, and we'll pick on Oracle Business Suite here. Well, in an Oracle Business Suite environment, well, I've got the known application places. I can actually call Oracle. They'll give me an okay list of where the sensitive data is within Oracle eBusiness Suite environment. What they won't give me is a bunch of other locations. They won't tell me where it is in terms of custom tables. So in terms of a lot of these package applications, I make a lot of customizations to the application. Every time I make a customization, I often create new tables. And then as an example, one thing we always find is when you've got like a large Oracle Business Suite HR payroll system, I often have a lot of inbound interfaces in and out. That might be the Blue Cross Blue Shield. I might have to be providing Social Security numbers. So what happens is I pull the information from the standard HR tables, I put it into a custom table, I process the data, I write it out, and then I send that file out. So therefore now I've got like that Social Security number in a custom table. Well, my development team may not have documented that. They may not have a process that says, oh, by the way, we tell the DBAs every time we put sensitive data in. Well, this interface may have been developed 10 years ago before anyone really cared about this. So oftentimes in custom tables, we find a lot of sensitive data. And then oftentimes those tables aren't even used anymore. So it's very common that we'll go through and find within Oracle Business Suite, we'll find the 3 or 4 standard locations it is. We know those really well. We find those every time. And then we'll do very detailed sweeps and scans of the custom tables, and we'll find Social Security number 15 times in the custom table, even though it's just stored a couple times in the standard Oracle Business Suite. But the organization for customizations, interfaces, and things like that has to pull in and out Social Security number, and every time they do that, they're creating a table. They're storing the Social Security numbers there. The second major one we find quite often in especially package applications, but also custom applications, is the DBA is asked to do a SQL update. They are asked to do a change to a table. And this may be for like Oracle Business Suite or PeopleSoft. Oracle support says, oh, by the way, just go run this SQL statement to fix the data. Something went wrong. You call up Oracle. They say, oh, just run this SQL script against, as in this case, Oracle Business Suite, PRL people F, which contains national identifier, and just go ahead and make that SQL statement real quick. It'll fix the problem. They're very good about doing it in test and development, and then they go do it in production. And any DBA who is worth their salt will actually do a backup of that table first. And it is super simple within Oracle, in an Oracle database, to do create table as select. So it's almost instantaneous to actually create a backup table. So the DBAs will do that instantaneously. They'll always make a backup before they do these direct SQL updates. But the process then is that they will actually do that backup. They'll run the SQL script. And the first thing they'll do is call up the data analyst, the business analyst, or whoever found the bug and say, okay, I ran this update from Oracle, just as I was told, and go check it. Go make sure that whatever I did fixed the problem. Well, the business analyst may take they won't do it on the phone. They may take a couple days to do that or whatever. There may be a delay. And the DBA moves on to other things, and they'll totally forget that they made this backup table. It's not uncommon for us to do a data sweep and actually go through an Oracle Business Suite database and find the PRL people F table will actually have 10 backups to it. We find that in many Oracle Business Suite HR systems. We find the accounts payable tables that actually have 1099 Social Security numbers in them. We'll find 3 or 4 backups, because what happens is they're doing these occasionally, and this may be over a period of 5 years, and they just forget about them and they just kind of sit out there. And then they're very careful about purging data and masking data and doing these other things, but no one knows about these tables, so that those processes don't impact these. So then maybe they actually are cloning production down to test and development, and they say, oh yeah, we got rid of all Social Security numbers, but it's still sitting in these maintenance tables. This is a very common one. So we're probably, when we do data sweeps, we're probably finding 20% of the tables that we find actually are these type of maintenance tables. This is very, very common, much more of a problem than people realize. Number 3 here is interface tables. So again, a lot of applications in and out are actually have temporary tables called interface tables, and you actually write the data to, then you run a process that will actually process it and put it into the main application tables. Typically, the way these processes work is they flush out these tables. Once the process runs, it actually cleans these tables up because it processes the data. Okay, I process the data, then it removes the rows from the table. Oftentimes, what we find out is if there's error codes, things don't quite work right, the values get stuck in these interface tables. So oftentimes when we actually see another set of tables, and again, this is not as common, this may be 10% of the tables that we're finding in a typical sensitive data assessment, it's still there because again, what's happening is data is getting stuck. They may rerun the process, but those records are still in the interface table. They may be marked as in error state, but they're not getting deleted because they have to be there for someone to actually look at and figure out what happened. And they just kind of build up and sit there. The other day, we found 10 million rows in an order processing system that actually had the credit card numbers. The order was supposed to be removed from that order table, but if there was anything that went wrong in the process, those rows stayed. It didn't really impact the application, but those rows were still there. And so we found actually 10 million credit card numbers in an order processing system recently because it was an interface table that the order was supposed to go through, get removed from this table almost immediately, but things were not going up according to process and they were getting stuck. Again, that's where things kind of go wrong and where you get this sensitive data within an Oracle database. It's not where you think it is. It's not typically in the standard locations because everyone says, oh, no, it's not supposed to. It goes in through that table. It's only temporary. It's only transient. We don't have a problem with that. What happens when something goes wrong? And you kind of get this buildup over years. Another case in like Oracle Business Suite, you can actually have columns called flex fields that the business defines what goes in that value. And we've had certain cases where people are actually putting Social Security numbers in these flex field values because, again, I need to capture it for something. Something seemed obvious at the time from a business process design. I needed to put it into that module, so they're actually putting credit card numbers, bank account numbers, these personally identifiable information. And we start talking about GDPR. Again, GDPR scope is beyond just bank account numbers, social security numbers, credit card numbers. It's other values that may be getting into these flex field values. And when I look at the database, the column names aren't obvious. It's column 1, column 2, column 3, because Oracle doesn't tell you what you need to use with these flex field values. You can define it any way you want. You define it in the application, not at the database layer, because they just provide these columns by default. So again, those are very hard to find, but things may be getting stored there. When we start talking about outside of the database now, I may have sensitive data in a lot of different locations, even on the operating system. So a typical processing for an Oracle database is that in order to have an interface, some process moves that interface file over, FTP or secure copy or some way, they move it over to the database server and either kick off a process or on periodic basis using like a database job. The database then reads that file from the operating system and loads it into an interface table, kicks off another process, which then moves it from the interface table into the application. So again, I may have from like a Blue Cross Blue Shield interface, social security numbers coming in and out of the environment being stored in these flat files. And a very common way that actually process that invoices or that interface file is actually then back it up to make sure I've got it in case there's any errors, it needs to be reprocessed, etc. So oftentimes every single day I may be having this interface come and go, and it may be copying the file over, processing it, and backing it up. So I may have years worth of data in flat files still on the operating system. Log files are another area we often see problems with Oracle Payments, which is the credit card processing within Oracle Business Suite. You can easily turn debugging on that process. And we found many clients that have had debugging on for years and actually are writing out massive amount of log files that contain very detailed credit card information. I may have log files processing for my interfaces, and in some cases, we see the developer for some reason was just echoing out a lot of information as part of these interface processes that are then writing it out to the operating system. So very common to see that. So again, when you're looking for sensitive data, you have to think both inside the database and outside the database because it may be in multiple locations. There's also other locations within the database that we call transient locations. So this isn't really where sensitive data should be stored at all, but my developers may be just doing things really poorly. So the SQL statement here is a standard SQL statement. We name the table a very obvious PII data for personally identifiable information data. Personally identifiable information underscore data. And so this would be a SQL statement. And again, this should actually use bind variables, so it's a little bit more protected. But the process may be just creating these SQL statements within a process. This gets executed at the database layer. And so now this information will actually be stored potentially in multiple locations within the database. So within the data dictionary, there's dynamic views called $SQL. And $SQL bind data if you're using bind variables. And so when I execute that SQL statement, it will actually be stored in $SQL. Oracle is very good about keeping SQL statements around because it wants to reuse them. It doesn't want to have to reparse the SQL statement every time it sees it, because that's very inefficient. So what it does is it stores and keeps SQL statements that are executed in these temporary tables. Once I shut down the database, it clears all these out. But while the database is running, DBAs and other people can actually go into the $SQL tables and actually see what's happening, see these SQL statements that are being executed. And if you're including the data in there, people can pick it up. Auditing is another area where actually, in some cases, we don't see it very often for the audit trail. But if you set the Oracle database auditing to extended, or even if you use third-party products like Guardium or Imperva, and I have detailed auditing on certain tables, and that auditing may be turned on specifically for the table, or it may be if I'm auditing a role that executes a SQL statement, or someone who's executing the SQL statement has a certain system privilege, it may be audited. And in the Oracle database, I have to have extended. If I have extended auditing turned on, then I'm actually capturing the full SQL statement. So I would actually capture the SQL statement if in the Oracle database, in the odd dollar table or the unified auditing table, if I've extended database auditing turned on, and it'll end up in odd dollar. That's very common. We see that quite often that we need to capture every single time someone is doing something with bank account numbers or social security numbers, and they actually turn it on, and you'll actually have this information captured. Finally, the last one is probably not as common. We very seldom ever see this, but we have actually found it in a few cases where if you have tracing turned on in the Oracle database, if you enable tracing for a session, again, tracing is capturing SQL statements. So I'm capturing this SQL statement out to different locations. And in this case, tracing will actually, if it's enabled for the session, it will actually capture the full SQL statement. There's some other locations also. If I've archive logging turned on, I have log files that are generated by the database for backup and recovery. I've got that. I also have all this data stored in my backup tapes. So there's sensitive data is stored in many more places than you think. It's just not in that one table. Even the activity of the database is generating and storing these SQL statements and this activity and potentially data rows in different places, especially for like backup and recovery, archive logs, those things. Those are also stored, storing all this information. So what do I do about this? Now I've kind of got an idea. I need to go find it. I need to look for it. I at least may have a short inventory. What should I be doing? For your major applications, you really need to always have a detailed sensitive data inventory. Very seldom do we ever see that in organizations. That if I walk in and do a database security assessment, one of the first things we always ask for is, okay, where are social security numbers? Where are credit card numbers? And we do a lot of work for large organizations that have like 1,000 databases, 4,000 databases. We just completed one for a bank that had 4,000 different databases. We ask this question. So where are social security numbers? Which databases are most, because one of the concerns they had as well, they need to limit the social security numbers they were capturing within the entire financial institution, and it was just about everywhere. And very simple question is, okay, what databases have it? They didn't know. They couldn't tell us. And they had a massive amount of databases. Another organization only has 20 Oracle databases. However, very large Oracle databases. They were able to tell us out of those 20 that 16 of the 20 had social security numbers. The next question was, where is it in those databases? No idea. But we know it actually is there. So how are you handling this when you're doing actually cloning of the databases, backups of the databases? How do you actually know where that is? How do you know where to actually encrypt those values? Well, kind of the DBAs guessed, but we don't know we're getting it all. So that's why we actually hired you, was like a final comment on that one. So the key point here is always start with a data inventory. So you should be maintaining this. You should at least have your database inventory identifying which ones have the sensitive data, hopefully down to an element level. So how do you actually go about finding this data? So there's a number of different ways to do it. There is no good answer here. There's no silver bullet tool that will actually find all the data instantaneously, process it, and be perfect. Because again, there's a number of problems here is that where the data is stored is in many different locations. It may be intermingled with other data. It may not be clearly identified what it is. It may be in different formats. Because even if you think of social security numbers, they're 9-digit numbers. Well, are they stored in an integer column? Are they stored in a text column? Are they stored in emails that are maybe stored in lobs within the database? So it can get in there quite a few different ways. Is it stored as a number? Is it stored as a text field? Is the text field got dashes in it or some other character? Things like that. The one way that most people kind of look very quickly for this type of data is they use column names. So, okay, let's just search for social security numbers. Let's search DBA tab columns. Let's look for all those columns that have SSN, social security number, national identifier. Unfortunately, that gets you down the path a little bit. May find a good number of them. You may be kind of 60, 80% successful doing that. But it's not going to find it in many locations that are truly hidden because there is no standard naming conventions. The DBAs don't have a Bible somewhere that says, oh yes, if you store social security numbers in a database, it must be with the name SSN. That's not the way it works. So therefore, you really have to have some sort of tool that will actually crawl through the database, looking table by table for this data. And there's a number of products out there. Oracle has some. There's a number of third-party products. Integrity, we have our product called App Sentry, which has a sensitive data discovery module as part of it. The key is this is not a simple process. You're not just going to go through and just kind of run a tool really quickly because, again, Social Security numbers are 9-digit numbers. There's no way to really validate that simply and effectively. Many of these tools, when you run them, they'll actually find every 9-digit number you have in the database. That 9-digit number may be buried with other numbers, but you don't really know that. You don't know how to differentiate that. So to give you an example on how this process should work and the complexity around it is I'll kind of walk through you what our AppSentry tool does. So it has a number of different stages that walk through and actually analyze the data and then pass off the data to each additional stage. So when we're looking for sensitive data, AppSentry starts out with a repository that we have for the common applications that we EBusiness Suite, PeopleSoft, SAP. We know about 4 other applications. So we start off there. We start with the known locations. That's the easiest thing to do because we actually know what tables and columns the data is in, and then we can actually start looking, is there actually data in those columns? And then we do kind of the next level is the data dictionary analysis. Because the reason we're doing these first 2 stages are we don't want to actually have to do a data crawler. We don't have to want to look through all the data. Can we optimize this process as quickly as possible? So we actually do a data dictionary analysis. So we've got column name patterns. So again, we're trying to get as quickly down the road as possible. And so we try to match column names. So Social Security number, national identifier, credit card numbers, CC num, those types of columns. We actually even look in column comments. So we'll actually look through within the Oracle database. You can actually have comments on tables. We actually look through that. Very seldom do we ever find anything, but that's the level of detail we're trying to go to. And this is kind of to show you some of the examples of the problem. Then we actually have a data crawler. The only way to effectively do this at the end of the day is to go table by table, crawling in the database. And so the data crawler within AppSentry is actually taking every single table, every single column, and looking and doing advanced data sampling, pulling back samples from every table and checking against a set of patterns, such as Social Security numbers, credit card numbers, bank account numbers, bank routing numbers, date of birth, things like that. So even if you do all those things, you have a list of tables and columns. There are a massive amount of false positives in that data. So what we do within AppSentry is then we actually do a very rigorous data qualification. So there's a lot of work done in the data quality analysis area that we've actually used to say, okay, we've got this data. How do we try to make sure that it's not just a 9-digit number, that's truly a Social Security number, truly a credit card number? So we actually go through and qualify the data as much as we can. So like for Social Security numbers, we actually do an analysis on Social Security numbers within our tool to say, there's a certain pattern actually for Social Security numbers. So Social Security numbers were assigned out based on areas and regions. So if you, prior to I think 1995 or something, if you told me your Social Security number, I could actually look up and figure out where you were born and what year you were born in. So the first 5 digits of your Social Security number has some logic to it. If we look at credit card numbers have advanced set of information built in. So a Visa number always starts with 4. The last digit is a check digit. So we can take those 16-digit numbers and figure out if they're actually valid credit card numbers by doing this analysis. And then what we're doing is also going through that column and saying, okay, within this one column, like tax IDs, well, I may have some FEIN numbers. I actually may have some Social Security numbers buried within that. So we're actually getting down to that layer of detail to say, okay, within the data qualification, this one column may have 80–90% of non-Social Security numbers, but it may have 10 or 20% of Social Security numbers. So we're actually doing data distributions and pattern analysis to say, yeah, there's very concrete patterns in here. There's FEINs, that there's Social Security numbers. Therefore, yes, it does have Social Security numbers, but it's a lower set. And we're providing a quality confidence as part of this to say, yes, we're confident that this is a Social Security number. And then finally, we do a quantification to actually say, yes, within this table, there may be 1 million rows, that there's 950,000 credit card numbers in this. But by the way, there's some other data in it to provide you this overall confidence metric. So again, this is not a simple process. As you can see, these steps are going through. And so, yes, you can do a lot of this by hand but tools are really where you need to do this. Tools that are going through and spending a lot of time and effort trying to figure this out. Because again, if you just do a data dictionary analysis, you may get some of the data, but you also may get many false positives. If you do a data crawler, you'll get a ton of false positives unless you go through these other steps, and the tool does that. You're kind of sorting through especially for a large database. For a small database, you may have 1 or 2 columns, it's fine. But for a large database, like a data warehouse, running just a standard tool like the Oracle DB SAT tool will give you tons of false positives. It's very hard to work with. So a quick comment on table and column comments. This is one way we actually do search. Again, we don't find a lot of data there because it's not very frequently used. We've run up against one client that says, oh yeah, the only place we looked was column names and column comments, and that's how we base our information off of. Unfortunately, column comments aren't used. They aren't part of ANSI SQL. So like if PeopleSoft application has no comments on tables or columns. So these can be provided by the developers, but most often developers, even in standard enterprise development standard, that's not included as part of the development standard to say, oh, make sure you put comments in. Oracle EBusiness Suite, even this is a top tier Oracle application. Only 1% of the columns within Oracle EBusiness Suite even have comments on them. So again, that's not a very good way to look at it. We look at it to try to make sure, just in case somebody may have said it, but again, it's not something you should be relying on within the enterprise. So kind of the final piece here is, how do I actually protect some of this data? What should I be doing now that I actually have some idea where it is? What should my process be? And what steps should I do to protect it? And again, there's no good answer here. This is one of those that, depending on your situation, your compliance requirements, your sensitive data elements, your application, your database versions, etc., I can't just say, oh yeah, turn this on, you'll be protected. This often is database by database, application by application, and I can put in some general level controls. I can have strategies, but what I do for each database, even down to sometimes the element level, what I have to do may change, because I may not be able to do something in one application that I can do in another application just based on the data elements, where they're stored. Even if like Social Security number, if it's a primary key, it may change if it's a primary key or a foreign key, if I can encrypt it or not. So again, that's the challenge around here. There's no good answer. The idea here is you need to have a process. You just need to at least be thinking through what your situation is, what data elements you're trying to protect, and what you should be doing about it. So the first step is to actually have that privacy policy. What are we trying to protect? This is where a lot of organizations fail, because yeah, they have a great privacy policy that says we need to protect all personally identifiable information. And somebody from IT security or compliance sends that to the DBA and it says, we need to protect all personally identifiable information. That doesn't help the DBA, because they don't know, what do you mean by personally identifiable information? Oh, okay, we can get down to the next layer. All personal information, all salary information. Okay, we're talking about salary information. Standard HR system may have 30, 40 different tables that contain that information. So whenever we talk about data protection policy, we think it needs to be down to the data element level. It needs to say first name, last name, date of birth, bank account number, Social Security number, credit card number, down to that layer of detail. And then you can actually start doing your data protection design and data discovery process, that then you're kind of doing this at least annually on most of your major databases to get down to that detailed data inventory, down to the table level. And then the final step of that inventory is, what are we doing about each of those? And then step 3 here is, what are we doing about that? How are we actually protecting these elements? And again, this is where there's no good answer, because there's a number of different options, and depending on your current situation, the data element, the database, the application version, the database version will all have impacts on what you're doing. Because some applications will have native encryption, like Oracle EBusiness Suite encrypts credit card numbers and bank account numbers within the application. That's the best case scenario. That you want to do application level encryption wherever possible. Well, it doesn't do anything about Social Security number. So if I take a backup tape and I'm not encrypting my backup tapes, Social Security numbers are unencrypted in the backup tapes. So what do I do about that? So some Oracle databases, if you have enough money, you can buy Oracle Transparent Data Encryption, which will encrypt the entire database. And I'll talk about that in a second. How am I protecting this data when it's actually flowing across the network? So if someone's going and accessing that data and they're going in with SQLnet, is that data encrypted? So if I go in and actually select star from social security numbers from SQL Developer on my desktop, is that information encrypted back and forth? Depending on your database version, the answer is no. It's going across your network unencrypted. So again, that's often a piece that on the network transit, is it being encrypted? How am I doing access controls? We find so many databases that are signed out select any table system privilege. Very often that you see that system privilege granted out like candy, and you may have 500 users in the database and half of them have select any table. Again, that's not appropriate data protection. That is clearly a GDPR violation, clearly a PCI violation. HIPAA would probably have a problem with that too. Becomes a significant challenge. How am I actually auditing this? Who do I know who's actually accessing this information? Can I turn auditing on some of these columns? We're very cautious about turning on table level audits for any Oracle database because of performance issues. Because if I have a main key table in an HR system, my master employee table that has social security numbers, if I turn on select auditing on that, I can guarantee you'll have performance issues. So how do you get around that? So again, this is challenging to actually get to a very deep granular level of auditing. How am I doing this? How am I controlling this access controls, etc. The final step here is I'm actually potentially cloning these databases, just depending on your application, how it's set up. Typically in an Oracle Business Suite environment, you often do a clone, and a custom application on an Oracle database, not as likely to do cloning, but in some cases, you're taking the production database, cloning it down to test and development on a periodic basis. What am I doing with all those social security numbers, credit card numbers? Am I scrambling that data? Do I know all the locations? And now this is where our security assessments come in and say, yeah, we're finding those scrambling scripts. So when you're taking production, you take all the social security numbers and you scramble them to different numbers after you've done the copy. We actually look through that process and we're actually finding that very seldom done for every column. So they may have found 5, 10 locations of social security numbers in the database. They're not finding the 30 or 40 locations it truly is. Because remember, when we talked about maintenance tables, interface tables, it's often in other locations. And then finally, how are you hardening and securing the database overall? Are you doing just general security hardening on the Oracle database? Are you making sure that the initialization parameters are set right? Default passwords are changed, things like that. So when we talk about native application encryption, is the best case scenario. So when you're talking about protection, I want to encrypt it at the application level, because then even if someone has selected any table system privilege, they can't see the data. Oracle Business Suite is an example here. They do credit card numbers and they do some bank account numbers in the application, but they don't do them all. So now, how do I actually do encryption? Well, a lot of our clients say, well, we have to use Oracle TDE then. So Oracle TDE is a database encryption solution, but it's only encrypting it at rest. So if I lose a disk drive, if I lose a database file, so someone hacks into the operating system and steals the database files, basically copies them off. If I have a backup tape that's not encrypted as part of the backup tape solution, I then actually lose that data. That backup tape falls off the FedEx truck. That information is unencrypted. The key thing that people don't understand about TDE is once I'm authenticated into the database, if I just have a database account, I see that data as unencrypted. It is only encrypting it at rest, at the storage layer. So the disk drive, the database file, the backup tapes are not encrypted as part of TDE, or encrypted as part of TDE. But once someone signs in with a valid database user, it is unencrypted. Is that sufficient for your requirements? It has never been litigated as far as we know. Is that sufficient? Because again, a lot of the breach notifications are if the data that was stolen was unencrypted, I have to do a breach notification. Again, TDE is, yes, if they stole a disk drive, it is encrypted. I don't have to do a breach notification. However, if someone signs into the database, steals a database account, is able to access the data, they see it unencrypted. Therefore, it was not encrypted at the time of theft. Therefore, you have to do a breach notification. So this is kind of what you need to be thinking about is, yes, TD is a very good solution, but it is very limited. So you have to be very careful about when you're looking at TDE. TDE also can do column level encryption or table space level encryption. So again, some organizations will go through and pick off these columns, but if you're doing column level encryption, a lot of organizations don't know where all the data is. So they may have picked off the locations they know. And in most of our sensitive data security assessments, we're finding that they're only finding about 30 to 40% of the true locations. They're not finding everywhere it is. So column level encryption doesn't become effective. Table space level encryption is really what you need to be doing. And most organizations who are actually implementing TD are now encrypting the entire database. So you encrypt the entire database except for the system table space. That way you know you get it. If you can't do the entire database, we actually recommend you do, like in a package application, do all your custom tables, because therefore you don't necessarily know where the sensitive data is in those, and then you can do column level encryption for the known application locations. So again, this is all strategy on how you need to walk through it. Another tool Oracle has released, which is part of Oracle Enterprise Edition, is Oracle is actually giving you, as part of the Oracle database in 12c and above, the transparent sensitive data protection feature. This actually acts as a repository of all the sensitive data in your database. This doesn't do anything automatically. You can use some of the tools to populate this information, but the idea is that you're populating the TSDP tables with where you think the data is, and then the other additional features within the Oracle database will actually start using that to actually help protect the data. So there are some strategies, there are some tools out there to help you do this. Again, it's always custom, it's always very specific to your data elements, what you have to be thinking about within your database. And unfortunately, this is a database by database issue. You should be thinking about it as strategies at the enterprise layer, but when you get down to each database, you need to be doing it specifically. There is no single answer here. There's no simple way to say, oh, yep, we're going to do this for all 100 of our production databases. What you can do is, this is our strategy in a number of different areas. This is how we're going to do auditing. This is how we're going to be doing sensitive data protection. And then when you get into each database, you may have to tweak that because there's certain issues with databases. There may be an older database version. There may be application limitations. The application may have used Social Security number as a primary key, which therefore means you can't use column level encryption on it, things like that within the Oracle database. So I will open it up to questions. I'll turn it back over to Phil. This is our contact information. Again, a lot of the information that we do, we publish directly out on our blog at integrity.com. We also have a YouTube channel where videos like this and other webinars we give are all available. Phil, are there any questions? Are you still on mute, Phil?
How'd you guess?
Yeah, much better.
Thank you, Steve. Yes, we do have a couple of questions here. Let me, here we go. First one, is it better to stay with the Oracle solution, which costs a fortune, or look at third-party products?
This is always a hard one because it just really depends on your requirements. The Oracle solutions, the Oracle tool DBSat is a free tool from Oracle. It does an okay job. It will raise up a bunch of false positives, but it'll actually show you a number of locations. You do have to weed through the data. Some of the data masking tools within Oracle are a little bit better. The Enterprise Manager, Data Discovery, again, does a decent job. However, the third-party tools will go to that next layer. So like our App Sentry tool, we're doing the data qualification. So what we're trying to do is reduce that number of false positives. For a large data warehouse, if you run some of these tools, you may get 500 locations. That's not uncommon. So then the key is somebody has to walk through all 500 locations and try to figure out which ones are actually valid Social Security numbers, which ones are just 9-digit numbers, et cetera. So again, you have to look at each tool. How big are the databases? How many databases really becomes a challenge. So I definitely look at some of the tools like DBSat first. Does that work for you? If not, start looking for other products.
Okay, next question. if you do data scrambling / masking on a cloned environment, do the application testers run without problems?
So the biggest challenge when you're doing scrambling is the application testers say, oh, we need valid data. We need the best data possible. We can't do it if you're actually scrambling the data. And then oftentimes that it's a relational database. So there's a relationship between data elements. So if I take a social security number that's in 5 locations, if I scramble it to different numbers, that starts to become a problem. So when you're doing data scrambling, you really have to look at what the data elements are, what the testing requirements are, and try to come up with a way to actually solve that. So one of the ways we do it, if we kind of assist clients doing the scrambling scripts, is for like social security numbers. What we do is there's some logic behind social security numbers. Nowadays they're assigned randomly, but they used to not be. So if they start with a 7, it used to be for railroad employees. Don't ask me the history behind that, but social security numbers that start with a 7 are actually for railroad employees. So what we do on typically our scrambling scripts is to generate social security numbers that are consistent across all columns, is we always start them with a 7 and just then append the employee ID number to it. So because most often in these tables, employee ID is very consistent, or there's some other identifier that is found in every single table that you can reuse. So to generate that scrambled social security number, don't just make a random number, have it start with a 7, then use the employee ID, and that becomes a social security number. That becomes very consistent. Most often you have that number. Then the greatest thing about that is for organizations where we've implemented that scheme, we often get a call like a while later, and like it becomes an ad hoc control because everyone knows that the scrambled social security numbers start with a 7. And we had a call kind of a year ago that someone said, thank God you put that in, because someone started loading production data into one of the test environments. And one of the application testers caught it right away because they started seeing social security numbers that didn't start with a 7. And instantaneously they knew that they had a problem, that there was production data in their test environment. This organization had a data breach, so they were very strict about what they could have in their test development environments, and that became an ad hoc control. So there's things that you can think about when you're doing the scrambling like that to actually make the data elements. So again, it's consistent by using just 7 employee ID, but also that becomes an ad hoc control. So oftentimes we see production data being accidentally loaded into test development, or some developer just does it without understanding the security consequences.
Next question. If we are not applying Oracle critical patch updates, does Oracle TDE help us against SQL injection attacks?
So good question. So Oracle TDE is Oracle Transparent Data Encryption. So that's the disk level encryption. But again, any application or anyone signed into the database sees the data totally unencrypted. So SQL injection protection, there's no protection by implementing TDE, because again, SQL injection is an application level, a database level attack. And so any of those attacks will see the data totally unencrypted, and TDE will have zero assistance or protection with SQL injection attacks.
Okay, excuse me, so I'm going back and forth here. One more. We currently mask sensitive data when cloning our production instance to test and development instances. Just this month, we upgraded to Oracle EBS 12, not R12. I'm an auditor and how do I know we are masking everything we need to?
And again, you can take their word for it, but most often they're not finding all the locations. So therefore you need some automated tool that will look through the database trying to find these isolated locations. And again, some of those tables that we identified, the maintenance tables, the interface tables, they won't contain all the sensitive data. And typically in a scrambling script, what we see is they know the really well-known Oracle Business Suite locations, but they're not finding the custom table locations, and they contain just as much as the standard tables. But like interface tables may have a subset. So if you've got 1 million social security numbers, Well, if you look through interface tables, you may find 100,000 type situations oftentimes. So again, you need to be looking through the database using some tool to try to find that data, because it is scattered. It is in isolated pockets. It's in corners of the database, things that people don't know about. And oftentimes we'll talk to the development teams, okay, tell us where all the security numbers are. And they say, oh yeah, it's in 5 locations. We've done a really good job. And we look and it's in 20 locations. That's a very common situation, happens all the time with the vast majority of our clients. Only occasionally do we run into a client that's actually done this really well. Most often is they've done an okay job, but they only caught 50%. To me, you've done actually a pretty good job if you caught 50%. You've actually thought through the process, where probably a bunch of clients have never even thought about this. They have no idea where it is in the organization. It's just scattered everywhere, and they had a breach, and now they really have to find it.
Well, thank you, Steve. And I want to thank you, all of our attendees today, for attending our e-learning session today. And be sure to turn in this next month, January 22nd, when we'll be talking about security with the Oracle databases in the cloud. So thanks again, everybody, and have a great rest of the day.